Hello, my name is Håkan Norling, and in today's webinar we'll take a closer look at the rail signaling solution. The agenda for the webinar is that we will go through a few PowerPoint slides, and then we will do a demo of the rail signaling solution, and that will be two parts of that. One where we look into an existing project, and then we'll create a new project from scratch. Our electrical portfolio, we have promis.e, which is the solution for schematic diagrams and panel layouts, wiring diagrams, and so on. We got Bentley substation, where you can create a 3D model of the substation and tie that to the protection and control circuits. And we got Bentley raceway and cable management, which is the expert application for cable routing and building up the raceways where we can run the cables. And then of course we got the rail signaling solution. The Bentley's rail solutions, where rail signaling is a part of that, but we also got the Power Rail Track, which is the solution for track design. We got PROL, or the Power Rail Overhead Line, which is used for the catenary design. And then we got Bentley's substation, as we just mentioned. And of course we got the product-wise and asset-wise solutions, and we also got OpTram. Rail signaling design. We do have a centralized database where we store all the project data. And we also got a concept which we called modes. And if you simplify it a little bit, a mode is a particular type of a document or a model. So we have a 3D layout mode, where we build up a 3D model of the railway corridor. We also got a track layout mode, which is the route and aspect drawing or instruction drawing or your scheme plan, where the track is normally represented as a straight line. We got panel mode, which we use for designing the interior of the panels. And we also got schematic mode, where we have the wiring of the circuits. If we look at modes in a slightly different view, we have Oracle or Microsoft SQL Server as the database vendor. We can run everything under product-wise. We've got rail signaling and promis.e, which has microstation functionality included. And all of this will provide us with an integrated electrical object data model. And if we then place down a component in one of the modes, that component will only be stored once in the data model, but we can view the same component in a different mode. The components can be represented as a 3D model or a 2D symbol or a combination of both of those. The 3D model should be scaled 1:1, and the 2D symbol is normally upscaled, and the purpose of that 2D symbol is for printing. So if we print out a model in a scale 1:1000, the 3D model is usually too small to be visible on that printout. Got another toolkit which we called hook points, and there are different type of hook points for different purposes. We got anchor points, and those anchor points can be embedded into a catenary mast, for example. And then we can utilize that hook point for mounting objects on that catenary mast. So like this picture here on the right, where we got a junction box there mounted on the catenary mast. And we can utilize that hook point to snap those two together. We've got another type for trenches. So that will be your connection point, if you like, for the trenches, so we can build up the trench network. We also got hook points where we can connect cables in the 3D model. So the cables in the 3D model will provide the system with information, what type of cable it is, the cable name, and the from and to information. And also, if we have a trench, we can associate that cable with a trench, so we know where it's physically routed. The actual 3D model of the components that we place down with the rail signaling solution. What we see on the screen right now is a small but typical example of what we're actually designing. So we got a signal with foundation, a signal mast, and a signal head. Got junction boxes, we've got manholes, and we've got trenches. We've got trenches, conduits, and we've got a control house as well. Worth mentioning here is that the rail signaling solution do not only deals with signals or signaling equipment. We can use this solution for designing low voltage electrical or telecom, for example. That works fine as well. Within a project, we definitely need a track alignment. So we can utilize the track alignment from Bentley Rail Track, and that will provide us with track names and station values, and of course also a graphical visualization where the track center line is located. Moreover, we can bring in the catenary equipment into our model to visualize the catenary mast and the cantilevers and the wires. And we can also add in the civil model, like the DTM, which will represent the ground surface. Since we are using the track alignment from Bentley Rail Track, we will have access to the station values, which means that any object we place down will get the station value from the track alignment. As we mentioned before, we can include Bentley substation into our rail solution and design the substation which will supply the power to the catenary system. We've seen a little bit of different disciplines that are part of a railway project. So normally there is a lot of reference files that will make up the total model of the railway project. Within rail signaling, we have a tool called Reference Manager, which will help the user to attach reference files. So with just a few clicks, you can attach 10 or 20 or 30 reference files to your model. The catalog manager includes the symbols that we are placing down into the different modes, and there are some default rails symbols that comes with the application. Rail signaling, what is it? It introduces intelligence into conventional rail system design, ties apart a catalog database and 2D schematics and layouts. We can link those to 3D layouts.
We've got a signal sighting tool built into the rail signaling solution. And with the signal sighting tool, we can drive up and down the railway and make sure that all the signals are visible and no other object is obscuring the signal. With Luminar-T, you can immerse buildings within a real-time visualization environment to help you tell better stories by allowing your stakeholders to experience your design. The picture that we're looking at right now is actually our model that we will be working with in a few minutes. So that model is exported from rail signaling straight into Luminar-T. and we can do some visualization work, walkthroughs and fly-throughs, and add vegetations and simulate the sunlight depending on the time of the day. Here's another example of a LumenRT model. You can change the seasons so the leaves on the tree change, and you can add people and items to your model to create a real and interactive environment that you can then share with all your stakeholders. Context capture lets you take pictures with a digital camera to create a 3D mesh out of the pictures. So you can take a drone and fly over your area and create a 3D mesh, and everything can be merged together to show how your project will look like in the existing environment. And the picture we are looking at here is from a train station in outside London, UK. That context capture model or 3D mesh is created from pictures only taken from the platforms. So even if you don't take pictures by a drone, the level of details will be extremely good. So here's an example of a model of a plant with context capture. Even if the model is quite big, it goes down to a very high level of details. Design content. What's different in Connect version? You can browse, select, download and register design content with a project through the Component Center feature. Easily share, modify, control content throughout your projects, across projects and users. Reducing duplicate efforts and out-of-date content. Catalogs are available at designers' fingerprints. You can store non-graphical data and documents with the engineering model. With Connect Advisor, you can get product training and information you need when you need it, without having to leave the design application or search for relevant content. Learn interactively, discover live events, and get personalized recommendations. And you can interact with thousands of experts. This is how Connect Advisor looks inside a Bentley product. In this particular case, it's EcoSim Building Designer. You can see the drop-down menu on the right-hand side, and you can see how videos play in the middle, directly in product. Now we will move over to the product demonstration. So let's take a look at an existing project. My project got schematic diagrams, we've got panel layouts, we've got a track layout, and we've got a 3D model. So we'll start in the 3D model. So if you open up that one, this model is consolidated by catenary design, a digital terrain model, track center lines, and some components that we have placed down with rail signaling. And if we move the project around, it is a small but quite typical project. If we zoom in and take a look at that signal head and the device ID for the signal head, it's got a unique name and it's also got a part number assigned. If we look at the attribute for the same signal head, it will have an offset from a track center line, and the track that we have measured the offset from is the main track. We also got a station value and a rotation, and we got an XYZ coordinate. And these attribute values are automatically applied when we place down an object. This signal head is also placed in other documents in my project. But please note that the component itself is only registered once in the data model. So if we right click on that, we can navigate to the track layout, where it will zoom in and highlight that signal A. And furthermore, we can navigate into the schematic diagram and see where this signal head is wired. The signal head itself is wired by a cable called cab 100, and it goes to the junction box that sits on the signal mast. And then we got a cable from the junction box on the signal mast, and which goes to or terminates on the cable terminals in the signal control house. So we will place down later on the cab 101, so if we keep that in mind. But let's go back to the 3D model. If I want to place down the signal B next to the side track, there are a few ways to do this. One way is to use the place symbol tool and the identify feature and identify any existing object. It will configure the dialog box exactly as that component is placed down. And here we can change the name of that, and then we get an option to place a new instance of that particular component. So we call it B, and we will place it down using track and station values, but it will associate this with the side track. And if we place it down, I can then choose if we want to place it on the right or on the left hand side of the track. Place that down there. The signal head B, again, it's placed in other documents in my project, so I can pick that up from the list here. So if I pick up the SHTSB, which is the signal head, we can then choose to place this with the hook point method, and we'll flip it around, i.e. we will rotate it 180 degrees. Once I hit place there, and when I come close to my signal mast, it knows automatically where this could be placed. And because that signal head, as we said, is already in different documents in my project, we can right click and hit navigate and go to the track layout or the schematic mode, where that signal head is also represented in my project. Let's take a top view and bring up the tool for placing cables. Remembered in the schematic diagram we had a cable called cab 101. So that one is registered in the data model already, so I can pick it up from here and it automatically knows what part number it has. The placement method for this, we can say follow cable path, and if we hit place it will ask me for the starting component. So we'll select the mast of the signal, and we will select the signal control house. Then it comes back and give me all the options how to route this cable from from the signal to the control house. We could have ticked the option saying use the shortest route, and in that case it would have picked that one. And if we hit apply, it will place down that cable into the trench. If we zoom in a little bit closer, we can actually see the cable over here. And if we right click, we can hit navigate and navigate where this cable is also represented in my project. So if I select the fourth core, it will go straight into the schematic diagram and highlight the fourth core of this particular cable, or named cab 101. Right, so let's go back to the 3D model again and pick the ISO rendered view. If we add a camera view to the model, turn on the camera. If we do so, we can use the fly-through tool. And the fly-through tool has some train heuristics, which means that we need to get a little bit into the alignment before the view can be configured. We can choose to follow the main track or the side track, and if we then move this just a little bit further, it can then rotate the view. And then we can just set the speed and drive forward. We can go backwards, we can have a look around, and we can go to the reverse direction. And we can also display a train cab around us, so we get a more realistic view of what the train driver actually will see. This will end the first part of the demonstration in the webinar, and now we will move over and create a project from scratch. So let's create a new project. We call the project demo, and it will create a new project, and it will ask me for a document in my project. We fill in some value for that document, and we'll select an initial mode as the 3D layout and a title block in the page format, and we will also key in a code which will give me the right level library. Click OK on that. We've got a brand new project and we've got an empty document. First thing we need to do is to attach some reference data. So we'll use the tool Reference Manager, and we'll go into the settings and activate the settings for the Reference Manager. Now when the tool is loaded, we can then attach regions, and with help of those regions as well as the settings, we can then attach background information. So if we use the tool for attaching model, and we'll select one of the region, and that will be the middle one, and we'll say clip the models to the region, and before you attach anything, preview what you have found. So if you click OK, it will tell me that we've found two models. Click OK on that, it will attach the models and cut them to the extent of the region. If we zoom in a little bit and turn the view around, we can see there is slightly too much information. So we can use the level setup tool and apply a predefined level setup. That will give me just the right information I need for my project. So let's rotate the view so it will be a little bit easier to work with. Okay, the first thing we should do is to place down some trenching objects. So let's bring up the place symbol tool and filter out a part number. So select a category, we can select a discipline, and then we can filter out objects for the trenching. Place down these components with the method perpendicular to track, we'll set an offset that will work with that particular library object, and if we hit place we can then select the track where we should measure that offset from. It will find its rotation according to the track, and we can then give the component their correct names. So place down 2 manholes, and we've got a conduit between those 2 manholes. Do exactly the same thing with another library object more suitable for 1 track, and we can place that over here, and that will be called KB3 and 4. If we take a closer look what we have done here, we have placed 2 manholes on each side of the track, and the elevation of those is aligned with the track center line. Next thing to do would be to place a trench. We will select the 350mm concrete trench, and the route name for that would be T1 or trench 1. If we hit place, it will ask me for a hook point, and that circle we see over there is a hook point. So if I select that one, we'll get a rubber band from that manhole, and we can go and find a hook point where we should terminate this trench. So in this case we got the trench aligned with the track center line and connected to that manhole. Next thing to do would be to place down 4 objects, and the first thing we should place down is a cable meter box, and we'll give that a name KM, and the method for placing that should be 3xy, and we need to select a track, and the third one down in the list is the main track, that one over here. If we don't know, we can select that one in the graphic. This object here is divided between the 3D model and a 2D symbol. The 3D model should be placed exactly where the component is located, but the 2D symbol we can place that where it fits. And the purpose of having both a 3D model and a 2D symbol is that the 3D model, if we print a drawing cut from this model, won't be visible in a scale 1 to 1000. So the 2D symbol is for printing purposes. So if we hit place, we will then get that 3D model, and if we place that one over here, then I get the 2D symbol attached to the cursor, and then we can place the ID for that. If we then pick a transformer, we call the transformer TRF, and we can use the XY method again, but we can select an offset, and the offset to that track over here should be 3.6 meters. If we hit place, that transformer is then locked 3.6 meters from the track center line. Place the 3D model, and then the 2D symbol and the ID. We'll then pick a cable box. We can use the method perpendicular to track, and this could be 3.5 meters from the track center line, and this will be placed wherever I select the track. So if we say there, we can then choose right or left side of the track and then place the 2D. And finally we should place a fuse box. Call the fuse box FB, and the method will use a hook point for place that. Using hook point means a predefined mounting point. I can associate this with a track, so we have something to measure the offset from, but the station, distance, offset, elevation and all of that is controlled by the hook point. If we change the snap distance to 2 meters, it will be slightly easier to place this. If we then zoom in to that catenary mast, if I come close to it, it will automatically snap to any available hook point on that object. And please note that this catenary mast is in a reference file, so it's not in my active file. So if we place down that, and we can then place the ID for that fuse box. Just a quick look what we have done here. We have placed the fuse box up in the mast a little bit where that hook point was located. Okay, next thing to do is to connect those objects to the main trench. So we'll do some object trenching. Use the tool for placing a cable path and we'll select a type for object trenching. Call the route 01, hit place, and if we zoom into the cable box first, select the hook point, and if we go straight down to the main trench, it will cut the trench and connect to it. And we'll do exactly the same thing for the transformer. And it will cut the trench and connect to it. So we now got a physical route from the transformer over to the cable box. Next part in the workflow would be to place a cable. So we select a cable part number and we give the cable an ID. And we can set axis lock to y-axis, so it will be a little bit easier to draw the wires. And in this case, compared to the existing project we was previously looking at, we will draw the cables between the 2D symbols. So if we hit place, it will ask me for a hook point where I can connect my cable, and there are 3 hook points there on the cable meter box. So if we select any of those, it will attach to it, and when we come to another hook point we can terminate that. It will automatically snap to that hook point. Call the next one 11. That will go from the transformer, and we will terminate that at the cable box. And finally, number 12 will go from the cable box to the fuse box. Right, if we take a look at the models so far, you can see the 3D models are all aligned with the track alignment, but the 2D symbols, we have pushed those down to set equals 0. So those 2D symbols there are just there for printing purposes, but the 3D model will contribute to the BIM model or to the railway corridor, the 3D model of the railway corridor. If we use the tool to review and assign cables to paths, cable number 10 doesn't have a route because the KM is not connected to the trench. Neither is the fuse box, so that cable has no route between the cable box and the fuse box. But cable number 11, that has a physical route in the trench. So that cable there has been automatically assigned to that path. So it's 28.5 meters long. If we then take a look at the cable itself, we can see the quantity of that cable is 28.5 meters. And it will automatically get that from the route it's got through the trenches. Right, the next step is to create a track layout. So if we go to the project manager, I'll create a new page, pick the same kilometer, we'll leave the location blank, set the initial mode to track layout, and we'll use an A3 sheet for that. In the track layout mode, we can use the tool to create a new alignment, but the new alignment will be based on the existing one. So we'll select the main track, and we can select a station value where we will start and a station value where we will end our track. So let's select the kilometer 478, start at 0, select the same kilometer again, and it goes to the end of that kilometer. We can place this track in a scale 1:1, or I will use scale 3 because then it will fit within my A3 sheet. We also need to create a description of that. We can create a new one or append an existing. But if we create a new, we need to name that description file for it. and once we've done it, we can then draw this track alignment. If I put a point or a data point before the alignment ends, we can then insert a breakpoint and change the direction of it. If I put a point after, it will create that alignment. And this line here is now intelligent. It knows it's called that for the track name, and if we start on that, we can then track the kilometers. Since we have placed down objects in the 3D model, we can then populate those components within the track layout mode. We can use this tool here, and we can extract the data or extract the component from the 3D model. And then we can choose whatever component we would like to place in here. So let's take the fuse box, cable box, transformer, and the cable meter box. We can scale the symbols by the scale of the track, or just hit place and it will place them down exactly on the same offset and station value as we have in our 3D model. The workflow could be the opposite. We can actually start in the track layout mode and populate the component in the 3D model. That works perfectly fine as well. So let's place down a new symbol in here. So in this case, just pick a signal. Call the signal S1, use the 3xy method to place it, add an offset of 3 meters, and if we do that, we can then slide this along the track. If we bring in this dialog box here, which gives me the station value, we can say that this should be placed on 775. If we use that station, we have then locked the position for that. We can choose left and right side and place the ID for it. As we said before, all the components are a view of the data in the data model. So this cable meter box is exactly the same component as the one we have in the 3D model. So if we hit navigate, it will take me back to the 3D model and the cable meter box will be highlighted here. That new signal we add in the track layout, we can populate that one in the 3D model. So if we select that one here in the list and hit place, it will place down that signal, but in this particular case, of course, it's got a 3D model attached as well. Alright, so the final part of this webinar would be to have a quick look at the outputs. So if we bring up the reporting tool, we can then select one of the predefined reports like the bill of material quantified. If we do that, we can save that to various of 5 formats or just preview that on the screen. And this will give me a summary of how many components I've used with the same part number. So an interesting thing is that for the 350mm concrete trench we have used 768 meters, or almost 69. And it quantifies all the other components. We can of course do custom reports. So if we want to just view the cables, we can take a look at the cables, and this report will give me the information from and to for the cables, as well as the quantity of the cable. And finally, we've got an object list where it lists all of the components, all of the bits and pieces that we have put together so far. And if we go down to the end of the list here, it will sort the list by station value. And if you look at this transformer here, it's got an offset of 360 from that track at that station value, and the XYZ coordinate is following. With that, I would like to thank you for taking the time and watching this webinar. So thank you very much.